Hello everyone, this is Naga Krishna Koneru. I am a technical architect with over 11 years of experience in AWS cloud and automations. Today, I'm going to discuss about quantum computing and its implementation on AWS cloud. Quantum computing promises to revolutionize how we solve complex problems from cryptography to drug discovery by harnessing the strange behavior of quantum particles. Quantum computers can perform certain calculations exponentially faster than classical computers. This presentation explores how AWS is democratizing access to quantum technology, empowering more nations to explore the next computing frontier. Let's deep dive. The topics covered in this presentation are classical versus quantum computing applications, hybrid quantum classical computing, quantum programming languages, AWS quantum computing portfolio, quantum hardware and AWS bracket architecture design, getting started with AWS quantum computing access models, and the final topic is future of quantum computing. Classical versus quantum computing. The current classical computers use bits for calculations and computations. The bits can maintain the state of 0 or 1, whereas quantum computing uses qubits, where each qubit can maintain state of 0, 1, or both. To double the computation power of a classical computer, we need to double the bits. Whereas to double the power of a quantum computer, we just need to add one more qubit. That's the best thing about quantum computing. Quantum computing applications. Where do we need quantum computing? In drug discovery, supply chain, and traffic flow improvements, and especially in financial modeling for portfolio optimization and risk analysis. This picture explains about hybrid classical quantum algorithms, where we can see both classical computer and quantum hardware or a simulator work together, making it as a hybrid computing. In this hybrid computing, a classical computer handles the most of the work by doing the initial setup, pre-processing, and final analysis, and it controls a quantum computer like a co-processor. And when it comes to quantum computer, it tackles hard part. It runs quantum routines where the quantum effects will have, like superposition and entanglement. And then these results would be sent back to the classical computer for interpretation. This explains a hybrid model of classical and quantum computing together. And let's discuss about quantum programming languages. So we have mainly four quantum programming languages. The first one is Python with Qiskit from IBM. Currently, this is the most used quantum SDK, and Q Sharp from Microsoft, and Cirq from Google's Python framework. And the final one would be Amazon's Braket SDK. This is the native to AWS Braket. Let's discuss about AWS quantum computing portfolio. AWS quantum portfolio comes with main three aspects: Amazon's Braket, AWS Center for Quantum Computing, Amazon Quantum Solutions Lab. Let's talk about AWS Braket. It is a fully managed quantum computing service that lets design, test, and run quantum algorithms on different types of quantum hardwares and simulators. AWS Center for Quantum Computing, it is a research partnership with Caltech to advance quantum hardwares and algorithms. Under AWS Quantum Solutions, and they help various organizations to solve the quantum computing challenges. Let's talk about various quantum hardwares available on AWS for quantum computing. The first one would be superconducting qubits. These are among the most mature quantum technologies, and these are provided by IQM and Riget. And the second type of hardware is ion trap quantum computers, and these have been offered by IonQ. And the third one is neutral atom processors. These use arrays of neutral atoms that are manipulated by lasers. And this hardware is provided by QRA computing. And AWS also provides quantum simulators where organizations can test their algorithm on the simulators before actually getting started on the real quantum hardware so that they can do a pre-analysis and analyze the results. AWS Oscillate Innovation. This is the latest innovation being announced by AWS in February 2025, where this chip uses CAD qubit. The qubit stays on superposition of two states like 0 and 1 at the same time, while being more resistant to errors than the regular qubits. So it reduces the error corrections by 90%. This innovation helps the development of smaller and more reliable quantum computers like our regular personal computers. The Amazon Braket Overview service was launched in December 2019. Now it's generally available, and it is a unified platform for multiple quantum hardware types where organizations can explore various quantum hardware types as per their requirement. And it is a pay as you go service model where organizations need not to invest upfront, but they can get started with the service and they pay as they use it. A democratized access, it enables innovation for researchers and businesses by simply using it in a simple and fast way. How Amazon Braket works. First, we create algorithms with Python SDK, and then we submit quantum tasks to devices or simulators. Then run the hardware and classical computers. Like we run hybrid quantum jobs on quantum hardware and classical computers, and then we compare the results, and then we switch between hardware with minor code changes based upon how our results came up. And this is the Amazon Braket architecture diagram. Here on the left side, there are three ways we can interact with managed notebooks, local IDE, Amazon Braket console. These are the three ways where we can interact with Amazon's Braket. In this picture, in the middle, you can see Amazon Braket. So it has managed simulators that are being provided by AWS. And in the back end, you will see different types of hardwares, as we discussed in the previous slides. Hardwares are provided by various vendors. So based upon our requirement, we can choose which hardware is suitable for us. And AWS Braket can seamlessly interact with other AWS services like Amazon CloudWatch for notifications, Amazon S3 for storage of objects or data, and AWS IAM access management for permissions for role management, AWS key management for data protection. In this slide, it explains about how the quantum computers will process the operations. Okay, on a quantum computer, so the smallest execution is called a short. A single execution of quantum operation on a device is called a short. This one, the first one explains how a short works. So basically, we call it as a circuit. Okay, if we have more than 10 shots, okay, so we can combine it as a task and submit it to a quantum computer. So a series, it executes a series of shots in a single task. And the third option would be like hybrid job, what we saw in the previous slides. So basically, a classical computer and quantum computer work together to make it as a hybrid job. This hardware can be used on cloud on AWS as a pay-as-you-go model, or the hardware can be set up on premises, which would be incurring a cost. We can use combination of both cloud and local resources. And this is how we can get started with Amazon Braket. In the AWS console, we can search with Amazon Braket or simply type Braket. It brings us to a Braket console where on the left side, we can see devices, notebooks, jobs, tasks. On the devices part, we can see different hardwares that are so based upon the requirement, so we can choose our specific hardware, what we want to use for our operations. And the notebooks, we can write our algorithm here and submit it to the quantum computer and final slide of the presentation. So as we have seen that quantum computing can help us to resolve more complex problems. The current research is going on so that in the future we can have fault tolerant systems where we'll have less errors in the quantum computing analysis, and they can be used for the regular commercial applications, and then we can use it for cryptography. And also we should be seeing more quantum education coming up, like workforce development for quantum economy. At the end, we want to see a quantum computer as small as like our personal computer with economically affordable and less errors and feasible for all the quantum computing applications. Very much for your